Good morning, Fuzzy. Welcome. Are those Skylanders? Those are amiibos. I thought they could join us for class today. Good morning, Turbo. Yeah, that's Chris Pratt. Who plays Bowser? Who's playing Bowser? Do we know? Good morning, Bark King. Is that a name change by chance? Good morning, Synthos. Good morning, YCS. Yeah, those are amiibos. I don't use them anymore. I used to. And then my 5-year-old second cousin, who loves Yoshi, had a birthday this weekend, so I dug out all my amiibos and I gave him my Yoshi amiibo. So that's why they're out here joining us today. Just here to hang out, learn some computer science with us. No, I don't have any Skylanders. Good morning, Top Wolf. Good morning, Brandon. Good morning, Giovanni. Welcome. All right, let's see. Today we're starting some new stuff. When it turns 11:30, I'll talk a little bit about our test. In the meantime, I need to pull up some notes. We're looking at, let's see, not that one. That's good. Whoa. Morning, Cade. Welcome. Yeah, I'll do it. All right. It is 11:30. So we're going to get started. Let me pull open the class here. Come back. Thank you. Putting out good vibes today. Hopefully we have a good connection. Of course, let me know if anything goes down. Cox Internet was... I woke up this morning and it told me that I don't have to have internet today. I think I got that fixed, but we'll see. Happy Tuesday. I hope you guys had a wonderful weekend. And I hope that you weren't too scared about the test over the weekend. I don't know if some of you saw my email or my announcement that I sent out, but I have been grading them. I started last night, and I didn't have the grades hidden, so some of you probably got, I would say most of you got a notification about your midterm grade. That's not final. All right, it's not a final grade yet. I need to finish them before I make any adjustments. So far, it's looking like there will be a pretty decent curve. Okay. Nothing over 20 points, but it's looking like there will be a curve, so if you are worried, please just hold off for the time being. I will have those grades posted by the end of today. And then sometime this week I'll get to assignment 4 as soon as I can. I'm sorry about that, but I am a busy guy. Obviously, if you get 100% on the code grade, you make my life much easier because I only have to briefly, skim your code to make sure that you didn't just copy paste the output, right? So if you ever want to help me out, get started early on your assignments and get those 100s on the code grade, so I don't have to really spend a lot of time manually reviewing your code. All right? But I will get to assignment 4 here as soon as I can. Now that's our administrative stuff. We are going to get started with some new stuff today. Now, last class, we were supposed to talk about multidimensional arrays. That's going to be involved in your assignment 5. I will be posting assignment 5 today. I still have to review it to make sure it's all clean and good. But the instructor who made that is very similar to me, so I believe that assignment will be a good one. And it will be based off of our new subject here, virtuals. And like I said, I do think there's multi-dimensional arrays involved with that. So we do got to get started with that, and then we'll move into virtuals. Now, some of you guys saw that bonus question on the test at the end, and there was a multi-dimensional array involved there. So let's go ahead and take some time here. There's actually 2 things I want to talk about before I get there. For one, just by looking at those test questions, I'm seeing some very common mistakes. There was a few tricky questions on there. I do kind of want to talk about those real quick. I don't remember their numbers, but I do remember what was involved there. So let's just kind of bring them up here. I've got to make a new folder for today. Apologies for not being on top of that. Today is 2021 10/12, and we're doing virtuals. And we're going to need some text document, and this will just be I'll give it a goofy little name for now. All right, so the first thing that we're going to talk about is, I don't remember what question it is. I just said that. But we pretended to say have some class A, and in its variables, we had something like a string name, and I don't remember, perhaps it was an int age. And then in the public, I asked you guys to write the definition for a constructor that initializes these parameters. And I told you specifically not to change the parameter names. Mail asks, are we really ever going to code without namespace std? You can. I wouldn't recommend it. You'll find this everywhere. But if you don't use that std, anything that you use that's like related with IOStream, you're going to have to like use it as a namespace. So you can't do something like cout hello. You can't do it. See, it's red. You'll have to say, hey, please go into this namespace and find the cout. Please go into this namespace and find my endline. So if you want to do that, you're welcome to, but it's very annoying. I would highly recommend doing that. Same with the string here. You'll notice that I didn't know what that was. Hopefully that answers that question. Now, this here is tricky, right? Because when we type name here, let's pretend I had, this is number 1 up here, and let's pretend this is number 2. When I reference the name here, which one am I talking about? Number 1 or number 2? I don't know, let's say I give it like this. Which one am I talking about here? Is it number 1 or number 2? Talking about number 2, right? So you're kind of tricky. It's kind of tricky here. I'm always talking about number 2. That's because this is the most enclosed scope. This is the same thing as, like, say you have int I up here equals 5, and then you do this for loop where you say int I equals 0, I is less than 10, I plus plus. And then somewhere in here I say cout I. Say, which I am I talking about? Well, this I, its scope is only limited to this for loop. This I, its scope is outside of it. So in fact, when I'm talking about this I in here, we're talking about this one. It's the same thing happening here. This is the name and there's this name. They're both available, but there's one that's in a closer scope. And the closer scope is this one. So I'm talking about this. So this doesn't work, right? What am I basically doing here? I'm taking this and I'm setting it equal to itself. I'm setting it equal to itself. So there's actually 3 ways to do this. And you should know about this, all right? You should know about this. There's 3 ways you can do this. And some of you got it. I'm proud of you. I would say the most easy way is to force this on this name, which will then make this part reference the one that belongs to the object, and then this one belongs to the constructor. Now there's 2 more ways to do it. Does anyone have any ideas? Let's say I didn't want to do it this way. There's 2 more ways I can do it. Does anyone have any ideas? 2 more ways. Yes, so Synthos, that's correct. I can do this if I want to. Once again, that's me forcing the scope there. Say, hey, you can go into this scope and find the name. And then this one is referencing that one. So that's another way. And then the third way, I didn't spend much time on it. But I did, some of you, yeah, I saw, some of you did this dot thing that doesn't work. All right, you got to use the scope. The third way, I talked about this. It is in the notes, but I never really spent that much time on it. You can use the inline method. And this will do the same thing. So that one's a little bit trickier, but that will do the same thing. All right. When you're doing the inline method, these variables are being initialized before the body of the constructor. So it knows that this name is referencing number 1 here, and this age is also referencing number 1. It also understands that what's passed in as a parameter are these parameters. So those are 3 ways you could accomplish that. So that's the first thing. The second thing we had was a bit of another tricky one. We're going to pretend like we have some rectangle, int height and width, right? And then we had some, I don't know if it was width, it was probably length, now that I think about it. We had some int here, h, or w and l, right? And this code was given to you. And I think up here you'll see that they were initialized like this. They may have been. With the L, and then this one, the width, was initialized with the W. Right? And then we had some class B that inherits from this. Class B, and it was probably public inheritance from A. And in this class B, we added an additional variable. We made it 3 dimensions, right? This is like a 2-dimensional, like square or something, rectangle, and this is a 3-dimensional. So we're inheriting here, and I said, hey, you have got to initialize all of the variables, every single one of them, the length, the width, and the height. I said, finish this body of code. Now the obvious one is, hey, the height can become h. All right, you can do that there, or you can do it up here. if you want to. But then you're running into some issues here, right? Because you can't say my length is equal to L. And why is that? Well, length is super private, right? It's up here in A. It's not accessible. So what is the absolutely only way to be able to initialize that? There's only one way. Some of you got it. What do I have to do? What's the only way we can initialize that? There's only one way. Aside from changing this to say protected, but you're not allowed to do that. There's only one way. Assume we have this one here too, right? We probably had something like this. There was a default constructor. So, Chef says use a function. Yeah, you can, you might be able to use a function. Mail, I'm sorry. If you went to the bathroom, please rewatch the video. We did go over this in previous classes. This is the inline method. You can find it in the notes. I'm basically explaining what we did on the test. Chef says use a function. Now, you're not allowed to add a function, okay? Rather, you have to do the inline method. The inline method is to specify the constructor, right? So this is the only way that you can do it. I gotta make sure I got those right. With an L, so I gotta switch them around. Does that make sense? You have to specify a constructor call here. And Mail, just to answer your question, that height H is the same thing as doing this. It's just initializing the variable. So this is the only way you can do it. This doesn't work, right? This doesn't work. This is the equivalent of declaring a new object. This is the equivalent of saying, hey, my object. Right? You're just declaring a new object with a constructor there. That does not work. You have to inline it. Does that make sense? Is there any question about that? To answer that question, if you were to initialize these values up here, you have to call the constructor inline. That's pretty much it that I saw. That sports car one was a little tricky, but it's kind of the same thing here. You have to use an inline method. And if you're going to inline it, you have to pass the, say, sports car. A lot of you were putting like, string n in here. And then some of you would say down here that n is equal to sports car or something. That does not work. Okay. This is like a call to the constructor. You have to actually provide the value that you want. And so you would do it that way. So those are kind of the biggest things on the test that I saw that I know we learned. And they were purposefully a little tricky. All right, so I hope that you were able to learn a little something about that. If you have any questions, please let me know. But that's about it. Now we're going to move on to the fun stuff for today. Fun stuff includes paint diagrams and probably it's going to be some hard thinking. You're going to have to step outside of your comfort zone a little bit here and try to wrap your head around what is going on. Now, we're going to keep this pretty quick. We don't have very much time to spend on this, so I'm going to give you the code. I'm going to give you the images. If you do have a question, let me know, but we are going to kind of move through this pretty quickly. So let's start basic. When we're talking about arrays, they have a dimension. All right, so the most basic array is a one-dimensional array. All right, that's the most basic array. So you guys are very familiar with that. We're going to use these as pointers. All right. We're going to use these as pointers. And this will be array 1DA. And this will say, hey, equals new int, I don't know, 5. So what this looks like in memory, let's do a paint diagram, shall we? Is very simple, okay? In that, let's see. Wow, that was not at all what I wanted to have. Whoops. Sorry guys, I told you that I'm an alpha, I'm a paint master, but obviously I'm having problems today. So this is our array, and in here we're gonna have, I don't know, 3, 4, 5, some values, right? And as you know, the way that those work is that there's one memory location, right? There's one memory location. Okay? So that's going to be our goofy little array. And that's what this creates. So if you have that line of code in here that says int pointer equals new int 5. That's basically what that looks like. If you really want to get technical here, you've got probably an address up here. Okay, that could be 0x00a, something like that. So that array is what's leading this pointer. And now there are ints, right? So this is going to be a plus 4, and this is going to be a plus 4 plus 4. But they're all contiguous. They're side by side in memory. So that's our basic one-dimensional array. Now there's another way that we can make a one-dimensional array. There's another way we could do it. And it's using a double pointer. And the way I want to do it is an array of pointers. So here's where we're going to get a little crazy here. Let's bring up our notes. Multi-dimensional arrays. Right, so our 1D array, we'll call it an array of ints, or rather an array of objects can be represented with a single pointer. Right, so we'll say type my array equals new type some size. Now let's do a 1D array, but it's going to be an array of pointers to objects. How many stars do we need for that? Does anyone have any ideas? How many stars do we need for that? A 1D array, but inside of the array, we're not going to have these numbers, okay? We're not going to have these. We're actually going to have pointers. We're going to use 2, right? It's going to be an array of pointers. So the way that looks is you're going to have, say, type star star my array equals new type size 2 stars. But now we're not done. So let's say we do that. Let's say we do that. I'm just going to kind of save these as we go. Oops. There's 2 parts to it. So let's assume that everything works the way we expect. Let's assume there's no garbage values. And let's say that that array of pointers has 5 of them. What do you think, assuming no garbage values, what do you think those pointers contain? What do you think those pointers contain? Now we'll keep that. We're going to get rid of this stuff. Well, eventually they'll contain addresses, but right off the bat, maybe if there's no garbage values, they contain null pointers, right? Do you think that's fair, what I'm saying? Let's assume that in here somewhere you've got something like an NP. So there's a step 2 to this, in that we have to actually allocate every pointer individually. Are you having fun yet? So the second step to this is going to be this. We're going to need a for loop. I is less than the size of our array. And then we go my array located at I is equal to a new int. Yep, we're going to need a for loop. Yep, exactly. You guys are on top of it. Now, I'm going to keep all this code together so you have it. All right? Because I want you to get it right. So I'm even going to include the deletes with the statements, okay? I want you guys to have it. Obviously, I'll upload this code, but I just want it in the notes as well. So this is the initialization that happens here. Then if we want to deallocate that, well, we'll get to that. First, let's pretend that we did allocate this. All right, let's pretend that we did. Now, I'm not going to type out the things, all right? I'm just going to say something like a pointer here. All right, you're going to assume that there's some address in there. Hema asks, why do they start off as null pointers? Well, because for the same reason, let's see, I don't know, I'm getting ahead of myself here. So the first thing that you do is you do it like this. This is an array of pointers, basically. Try and keep the magic numbers out of there. And I can already see that I've made a mistake in our notes. Let's go fix that. Guess what? I have to put a pointer here. I have to make sure that it knows that I am talking about a pointer. So first thing we do here is we create this array of addresses. That's what we just did. So it's an array of pointers. 4, 5. So similarly, Hema, when I say something like int new pointer, what does this contain? Well, it could contain an address. It could contain a garbage value. But we want to, we probably want to make sure that it gets set to null pointer initially. But the point being that as soon as we declare a pointer, we know that it doesn't have an address in it. This one, as soon as we declare it, there's no guarantee. Actually, it's not even a guarantee. There is a guarantee that this pointer is not pointing to anything useful. So it's our job to say, hey, this pointer needs an address. And so similarly up here, I've allocated an array of these things. These are all little pointers in here. Okay? They're all little pointers sitting inside of this array. So I'm asking you, do you want to assume? Well, no. We know this. There's a guarantee that these aren't pointing to anything valuable. We have to initialize them one by one. So when you say, why do they start off as null pointers? Well, maybe they don't. Garbage values. But you need to assume that they don't contain anything useful. So that's the second part. Did I confuse you more there, or was that a reasonable explanation? Now we need to go in here and say, hey, my array located at I, right? So we're going to access these one by one. 1, 2. And we're going to say, hey, you are getting a new integer. So now, at this point, they all contain some address in which we can reference them. We can reference them. So please let me know if I confused you. This is going to be number B. Number B. It's like I'm Guy from, what is that, Home Alone? Let's see. So that's why you allocate new memory into the array of addresses. Yeah, so it looks like this on this little paint diagram. It's kind of disgusting. You may never. Well, actually, you'll have to do this. Virtuals are fun, and you will actually have to do this. There's a reason for this. There's a reason. But all these pointers are pointing somewhere else in memory. They're pointing somewhere else. And if you want to talk about it, it's, 5, 4, 3, 2, 76, something like that. So does that make sense? That's our next. It's a one-dimensional array, but guess what? It's using a double pointer here. It's using a double pointer. Now, kind of what's important to think about here is that this, let me see here. This first star is corresponding to the array itself. The second star means that that's what's kind of inside of the array, our pointers. We give array an address, and then we give an address to a member inside of the array. Yes. So Synthos asks, I assume we can make an array of pointers in multiple dimensions. Yes. We're going to move on to that next. Are we kind of following so far? This is the simplest we can get. Now we're going to get a little crazy here. Before we move on, we have to deallocate it. Now we have to go backwards. What's wrong if I do this? What's the problem here? Or is it okay? Does that work? Do you think? Do you not think? What could it be? You think that's okay? Yeah, it just deletes the array, not the elements inside. I need to deallocate each cell one by one. And I have to do it first, right? Remember, for every new, we need to delete. How many news do we have here? Well, it looks like that's 1, and then 2, 3, 4, 5, and 6. Excuse me. So yeah, I like to do a copy paste on this one for this, and then all we have to do. Now, what kind of delete is this? This is very important. Is this a bracket delete or a base delete? Look at how they're allocated. Obviously, this one is a bracket delete because it was allocated with the brackets, but what about in here? Is it a bracket delete or just a regular delete? It's the base one, right? Yep, just a regular delete. So far, making sense. So now we're going to move up to the kind of crazy stuff here. 2 dimensions. It is Halloween season, so prepare to be spooked. All right, so we're actually going to keep this. We're going to keep this diagram here, but I am going to take this part out. So we're about to have some fun. So now I want to make a 2D array, all right? So I should probably split these out just a little bit so I can remember them. All right. So that's our base 1D array. This is going to be number 2. Of course, if I want to deallocate that, I'm just usually going to copy paste this because I want to remember for every new I need to delete. And then I'd like to rearrange it. So I'll bring this down here. And then I'm going to just kind of fix this. What is this? This is a regular new, right? So I'll just take that out and I'll say, hey, delete that. And then this is a bracket new, isn't it? So I'll take that out and I'll say, hey, delete that. Make sense? We died. Are we back? Are we back? Tell me. Did we make... Of course. It's noon. I'm really sorry about that, guys. Are we back? Thank you. All right, so in case you didn't see that, I just kind of put that in there, right? That's our deallocation. So now we're moving on to the 2 dimensions, all right? Now there's two ways we can do it. There's two ways we can do it. I talked about it. So let's do the number 1 2D and the number 2 2D. Number 1 2D. And that is actually going to be similar to this one. This is a 2D array and 1 2 stars. 1 2 stars. Now what is this one? Well, this is going to be a 2D array of objects. This is a 2D array of objects. All right. So similarly, I have to do the exact same thing. Now, remember this, guys. When we have, this is kind of very important. When we have multiple pointers, we have to allocate one pointer at a time. So if this is on the left side, when we're allocating it, we need one less star on the right side. So notice here, we went from 2 to 1. And then what's on this side? Well, this is 1 star, and we went to 0 stars. Let's look up here. How many stars do we have on this side? 1. How many stars do we have on this side? 1 minus 1, which is 0. So we have 2 stars over here. How many stars do I need over here? Can anyone tell me? How many stars? I know we're a little bit behind now, but that's okay. I'll just get ahead of everybody while I'm waiting. One star, right? Yep. So we got 1 star there. Now we're in here. All right. Now we have to remember, we have to assume, what is this? This is a pointer, right? This is like, this is an int star. So we have to remember that this is, sorry everybody, that this is an int pointer. So if I'm going to allocate it, I'm going to do this. 0 stars. Now check this out. I can make this an array, a 2-dimensional array. You want to know what that looks like? Let's go look at it. What do you say? This has become something else. I can allocate, I don't know, we're going to put just something in here. Something, anything. Something, anything. I'm going to allocate an array to each of those pointers. All right. Now, obviously, it should probably be 5, but I don't know. It could be whatever we want it to be, right? It can be whatever we want it to be. So now I've officially allocated these to be an array of arrays. Having fun yet? It's an array of arrays. It's an array of arrays. You officially have a 2D array. What does this look like? If I were to zoom in on just this part, this is a matrix, isn't it? It's 2 tall and it's 5 wide. It's a 5 by 2 matrix. Right? Does it make sense? That's all it is. That's all it is. And so that's all we did here in the code was we allocated, this is going to be a 5 by 5 matrix of objects. And notice that the objects are contained within here, okay? The objects are contained within the array. Here's the object, here's the object, here's the object, here's the object. So you ready to go up? Are you ready to move on? Does this make sense, guys? Tell me. Does it make sense? I hope so. So if I wanted to access this, I can say cout probably array 2DA. This is kind of pretty important here. The first dereference will take us somewhere, and then the second dereference will take us elsewhere. Now, Giovanni says 5 by 5 or 5 by 2. I confused you. Yes, I did. Up here, I did a size. I guess I'll fix that. What do you say? Let's do a width is equal to 5, And let's do a length is equal to 2. Width and height, sorry. Width and height, all right? And we'll do it the way you said, because I was using just this size variable, but I can fix it. So the width, I want it to be 5, and then I want it to be, say, a height of 2. Is that better? So the first thing I allocate is the array of pointers at a width of 5. So what does that look like? That looks like this one. The first thing that happens here is this. This is the first allocation. You say, my double pointer is equal to a new int pointer of 5. And then the next thing is I have to go through each pointer individually. Pointer 1, pointer 2, pointer 3, pointer 4, pointer 5. And say you're equal to a new array of size 2. Okay, where does that happen? That happens here. Now if I want to access it, the first thing I need to go is I need to find the pointer I'm looking for. So that's the x coordinate, right? That's the x coordinate, so we're going to have to go find it. The x coordinate is 0, 1, 2, 3. Here it is. And what do we get back? We get back a pointer. This is a pointer. This is a pointer. So that means I can dereference it again. Let's say, show me what's at number 1. Now, I don't have to do this. I'm just putting the parentheses there to kind of point it out. But what we have here is a two-dimensional array. This first dereference returns a pointer. The second dereference returns the object. So the first dereference will take us to this guy. And then the next dereference will go in here and say 1 or 0 and then 1. And that means we're looking at this integer here. Okay? Two-dimensional array. Now deallocating that is almost exactly the same as this one. Okay? It's almost exactly the same as this one. Except, what do I have to change? Can anyone tell me? What line do I have to change? There's one line I have to change for that one. And I'll kind of pull open the notes here on the side while I'm waiting for a response. Next, we're looking at 2D array, an array of objects. It looks like this. New size, delete size. All right. Any ideas? Maybe not. Line 41 has to change, right? That's correct. You make that a bracket delete, right? Because now we're not deleting singles anymore. We're not deleting single objects. We're deleting arrays. We're deleting arrays. And then once we've deleted every array, we then delete this array. So now, things are about to get spicy. All right? Things are about to get spicy. Next one. Top Wolf, yeah, you are correct. I messed up. I definitely confused you, and I fixed it. So, it was initially 5 by 5 because I had it like this. Size, size. And then you guys pointed out that in the paint diagram I did 5 by 2. So it's only fair that I do it in the code. So I said, no, this is going to be a 5 by... Oh, you're right. 5 by 2. I'm sorry. Sorry, folks. You're correct. You're correct. Synthos asks, do you delete the array I or does the whole array delete? Both. Let me fix it. I delete each individual array and then I delete the whole array. That's the best answer I can give to that, if that's what you're asking. I have to delete each one individually, 1, 2, 3, 4, 5, and then I have to delete this one after they're all deleted all the little ones are. So I think for the assignment, if you guys are sleeping right now, now's the time to wake up. Because we are going to do the one, I think, most related to the assignment here. A 2D array of pointers. An array of 2D pointers. Ah! That's scary. That is scary. All right. All right, everybody. I'm going to move some things around here. Okay. We're doing a 2D array of pointers. How many stars do we need? What do you think? We're following a pattern here, obviously. So, you know, it's not like it will be super hard to guess, but let's say we do a 2D array of pointers. Any ideas here? How many stars? How many stars are we working with, folks? Three stars, yeah? Having fun yet? I hope you're having fun. I know I am. 3 stars. Let's add it. The 3rd star of doom. There it is. Boop. 3 stars. Let's make it here. All right, here we go. Int star 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 2D array B. So how many stars on the right side? How many stars on the right side here? This will be of the width. How many stars on the right side here? Now that I'm thinking about it, guys, I've made a grave mistake. I gotta fix that. I've made a grave mistake. Those can stay. 2 stars, right? 2 stars. Bum bum. 2 stars. Yep. So now we've got more stuff to do. Why is it mad at me? Oh, yeah. My bad. Can't do it that way. Now, we've got something else in here. How many stars now? How many stars now? We have to go a star at a time. We have to go a star at a time. How many stars now? What is this, right? This is a double int here, yeah? So 1 star. All right. Now, are we done? Are we done? Is this enough? Are we done? What do you think? Yes or no? Are we done? While we're at it here, I'll make my deletes. Are we done? Nope. Gotta allocate each cell. Guess what? 4. Int j is equal to 0. J is less than the height. J plus plus. Array 2b 2db at I at j is equal to a new int. Are you having fun yet? I ask you, are you having fun yet? Yeah, so the width we've already taken care of. Now we need a height loop. So when we're deallocating it, no, we're not done, right? We have to go through each object first. We have to go through each object first, delete, and then we have to delete the array, and then we have to delete the bigger array. (404) error fun not found, right? Are you having fun yet? This deletes each individual item. This deletes the array that contains the pointers. This deletes the array that contains the pointers that contain... Bleh. Let's make the diagram, okay? Let's make the diagram. Now, I think that one will work. We'll test that on Bobby to make sure, because I think if there's anything you need for your assignment, it's basically this one. But let's look at the paint for us, okay? So guess what? This one looks a little bit different, and it's going to look nasty, guys. I just can't help you with it, okay? I just can't do much here to help you, like, visualize this other than making a disgusting paint diagram. But these are all pointing to things, okay? They're all pointing to pointers somewhere in memory. This one's pointing to something. I can't do it. You know what I mean? This is pointing to something. This is pointing to something. This is pointing to something. And then this here is pointing somewhere. Right. This one's a little tricky. All right. And then guess what? Where are the ints? They're there. They're there. There's your 4. Now you're asking me, why the heck would we ever do this in our lifetime? Right? Why would we ever do this? Is there any reason to do this? Well, there is, unfortunately. And that has to do with today's subject. So we're going to move on to that. So, as of right now, do you have any questions about multidimensional arrays? Now, we're not going to go any further than this. This is the only one that matters, really, for the class. You can go up. You can keep going. You can make an endless... You can make an endless multi-dimensional pointer if you want to. Now, the biggest issue with it is int star 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 equals, you know... We're not going to go that far. Let's do it this way, say. Equals, you know, array 3D. You have to allocate each star. That's the thing. You have to allocate each star. You have to go to 2. And then you have to do a for loop. And then you have to do 1 star. And then you have to do a for loop. And then dot, 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 and dot, 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 and dot, dot, dot. Okay. Oh, yeah, thanks. This makes sense? Let me see here. What are you guys talking about? The top left one? Are you talking about... Oh, yeah, you're right. You're right. You're right. Psh, you guys are right. Thanks for watching out. You don't need those. You guys watch me and you're probably like, yeah, this guy doesn't make any sense. That's better, right? So all the pointers are pointing to something. We fix that. All right, so you can make an nth dimensional array, but you need a lot of news. Okay, you need a lot of news, a lot of stuff going on there. So this should all work. I'm just gonna run it, and we'll see. It's not gonna have any output, but we're gonna make sure that the Valgrind doesn't have any issues with us. I don't know if I have any Valgrinds here. Maybe we can find it. Ooh, okay. We had some issues. Let's go find them real quick, and then we're going to move on. Yes, and yes, that makes sense. This one is size, BB, BB. That one makes sense. This one is the width, height, delete, delete. It's got to be on this one, huh? Let's see. We allocate some width here, 2 dB. We allocate some height there. And then here, array 2 dB is equal to new int. And then delete array 2 dB. Let's do a full leak check, shall we? Oh, nasty. Conditional jump depends on uninitialized values, huh? Can you give me a line? 36? What are you telling me here? Oh, yeah, maybe it's that. I didn't put anything in there. Let's see if that fixes it. Is that a nasty error to get just for some small little thing? I think I did that. Much better. Look at that, guys. All of this reduced to that because I was doing something with an uninitialized value. Very nice. All right, we're moving on from this. So let me know if I need to go back. I'll add all this to the notes, okay? I'm not going to take much time to do it now. I'll do it in the off time. We did do the pictures and we did do the code. So you have that for the assignment, right? When you get to that part, I think it's a fish tank. You've got this code here, all right? You're going to have to change it up a little bit, but I think you guys are, you know, strong enough to do that for yourself. So now we're going to get into the fun stuff. I mean, I guess, I don't know, depending on your definition of fun, this stuff's probably a little easier, therefore maybe a little bit more fun for you. And that subject of today is virtuals. Okay, that's what we're talking about today. Virtuals and abstract classes. So we just got to go through some notes like we always do. All right. Now, when we talk about virtuals, a class is always involved. All right. So this is not like function overloading. This is not like, I don't know, pointers. When we're talking about virtuals, we're always going to be using a class. A class is required. Similar for inheritance. You can't just do inheritance without a class. In order to do a virtual function, you need a class. In fact, you also need inheritance. Let's see if that's the next thing. Inheritance is, I probably spelled that wrong, didn't I? Maybe I didn't. Inheritance is also used. All right. So virtuals is always using classes and inheritance. CS202 student made a good point. Yeah. If you are a good person, you're welcome to do this. This prevents the dangling pointer. Now, if you're confused at this at all, my program runs fine without doing this. And the reason is because I'm not down here somewhere trying to say, hey, let's go back to that array I made, array 1DA at 3. This is where the problem happens. This is where I would be accessing the dangling pointer. because I know I'm confident in my coding skills, I didn't do that up here. I didn't set it because I know that I'm not going to be accessing it. But if you want to be a professional, oh, not there. By all means, you can do that. Does that answer your question? If you want to be a professional, unlike me, you're welcome to do that. I'd recommend it. I just know for a fact that I'm not down here messing with them. If you think you're going to keep using that pointer, then for sure set them to null pointer so that your program will segfault instead of altering your brother's Minecraft program, right? So in case you didn't get enough of pointers already, whenever we talk about virtuals, there's always a pointer to the base class involved, okay? Involved. All right, so if you haven't had enough fun with pointers, well, we're not done yet. So what does that look like? What am I talking about here when I say that? Well, let me show you. Let's bring in some program stuff here, my favorite. It just means that I'll have, say, class A. Whatever, my class A contains nothing. And then class B, which is inheriting, say, publicly from A. Say it contains nothing for now. And here I am in main, and I have something like this. I have a base pointer. Now, what can I do with this? Well, guess what? I'm allowed to do this. I can say, hey, is equal to new A. Is there something else I can do? I just kind of, this is kind of a vague question, but I want to see if you have any ideas here. Based off of the code I've typed, is there anything else I could store in that base pointer? What do you think? Is there anything else I could store inside of that base pointer? Might be similar to saying, you know, say we have a mammal. And then say we have Patty here, all right, my cat, inheriting from a mammal. Then we have a mammal base pointer, right? And I can say, hey, this equals a new mammal. Yeah, I could also store a derived class in there. Cat. Whoops. Right? Class B. I changed it last minute, right? So guess what? Now we're opening some ideas here. Whale. We're opening up some ideas here. All right. This base pointer contains a cat. And let's say I delete it. And then I say, hey, base pointer equals new whale. Now it contains a whale. Now you're probably going, why the heck? Why the heck are we doing this? This doesn't make any sense. Well, you'll see. You'll see. But that's kind of the idea I want to get into your head here. What do we have? We have a pointer to the base class, right? That's a virtual alert. We have a pointer to the base class, virtual alert. What does that mean? Well, we are going to be storing objects of derived classes into that base pointer. All right? Okay? That is how virtuals are used. For example, say from, I just gave you that example, right? But we could say, hey, player, new player equals new red player. Hopefully you have flashbacks to your assignment 3. We're actually going to be doing an example with that same code, All right, so when we get to the example, probably next class, we'll be working with the players. We're going to be doing the player stuff again, okay? That's the best way to talk about how this stuff works, in my opinion. So now we need to talk about what's the point of using virtuals. First, the definition before I give you the example. So you might ask, how do virtuals help us? Meaning, why can't I do it this way? Let's say I did this. So let me ask you this question then. Let's say I altered my code to do this. Now this works, by the way. Notice I've changed this to, and for those of you who had problem with this on the test, this is a static runtime variable, right? When I say static runtime variable, that doesn't mean I put static out here. Does not mean that. Just means that this is not a pointer, basically. This is me telling you that this is not a dynamic variable, right? This is a static runtime variable. When I do this, now I'll show you, here's the thing, all right? Here's the thing. It's time to open our brains out here, all right? Void, make sound, constant, cout. What sound do mammals make? I'm a mammal. No sound. Okay, now let's do some of this stuff down here. Kind of going all over the place here, I know, but what happens here? What is this called? I've just defined a function with the same exact name and same parameter list. What did I just do? What did we call that? That was on your test. What do we call that? What's that sound Dory makes from Finding Nemo? Ooh. Right. And yes, you're right. Synthos, Top Wolf, and Chef, right? These are function overrides. We're making some overrides here. Speaking of, that should go in our notes too. Okay, so I'm going to ask you now. I'm down here, and I've said this. I've said, base pointer, you're equal to a cat. All right, now remember, this is not a pointer anymore. This is a static runtime variable. What message do I see here? Give me a 1 or a 2. 1, I'm a mammal. Or 2, do I see meow? What do I see here? Number 1, is it I'm a mammal? Or number 2, is it a meow? What do you think? So static runtime variable. Who thinks 1? Any votes? I think that we'll probably see number 1. Shall we go check it out? Some people are saying meow. Well, that would be super helpful, wouldn't it? If it actually did that. ./a.out. I'm a mammal. I don't make any sound. That's not very helpful to us. So Uchu, you were right. What happened here? Well, this was upcasted. That's the term we use for that. It was converted. It was changed. The cat became a mammal. That's annoying, right? I really want this to make a cat noise. And in fact, I want this down here to also make a whale noise. Let me jump ahead here a little bit. What do you say? Let's jump ahead here a little bit. So let's actually keep this as it is. Now we're going to use virtuals. Now virtuals are going to make us make that meow sound, or we're going to make that Dory sound from Finding Nemo, right? I'm going to change these all to be named base, and then we're going to come down here and we're going to alter this code to make it do the one that we want it to do. All right, so this is what we know, and this is with virtuals. All right, so what we need is a mammal base pointer. All right, let's probably set it to null pointer. That's a virtual alert. All right, so virtual alert right there. And then we say, hey, base pointer is equal to a new cat. And then if I want to make a sound, well, I can't dot operator it, right? I'm going to use the arrow. And then when I'm done with it, I'm probably going to delete that base pointer, right? And then if we're professionals, let's say, hey, that equals null pointer. And then let's move on to this next one. Equals new whale. Base pointer, make that sound, please. And then we'll deallocate it. Now here, what I want to see is meow. And what I want to see is, ooh, right? I want to see that I'm a whale here. These are the number 2s, right? That's the goal of the virtuals. Now, as it is right now, we're not going to see what we want it to, because we actually haven't specified anything to be virtual yet. So this is important time to pay attention. We've only got 7 minutes left. I'm not going to be doing very much notes, but if you watch this now, while you go to bed tonight, your head will think about it, and you'll go, oh, that kind of makes sense, okay? So if you're asleep, it's time to wake up. Let's look at what happens here. So if I compile this right now, and I run this, I'm still getting this same output. I'm a mammal, no sound. Well, this is where we introduce the virtual keyword. This is where we introduce the virtual keyword. Now, I'll put this in the notes. Don't worry, we're going to review it next time. We're nowhere near even, scraping the iceberg with this. But if I make the member function in the base class virtual, it now is going to make the program work the way we want it to. Now we're definitely going to need probably some whiteboard for this. But do you see how the output changed there? See how the output changed there? And why does it do that? Well, here we have our base pointer to the mammal. All right, and I allocate a new cat in there. So this mammal pointer is holding a cat. And then I say, I want you to make a sound. So what it kind of does here is it's going to look at its inheritance hierarchy. Okay, it's going to look at its inheritance hierarchy. And up top we have the almighty mammal class. And on the sides here we've got a whale and we've got a cat. All right, this is the almighty mammal. And in here we've got a cat, and here we've got a whale. All right, and they are inheriting, right? That's our little arrow here. Pretty terrible if I do say so myself. And basically what we did was we said, hey, you've got this virtual function up here. That virtual function is called make sound. And these each have their own void make sound. So whenever I call, so I called make sound from the cat. And it's from a base pointer, but the runtime is going to remember where it came from. So I call make sound, and it comes up here, and it says, all right, what member function was called? And was it virtual? Well, yes, it was. It was virtual. So now it's going to follow down the arrow until it finds what derived class is stored within it. And here you see that the cat has a make sound, and it says, all right, I'll call this one. So I'll leave you with one more thing today. Let's say we make a new mammal class. What mammal doesn't make any noise? I guess they all make noises, huh? I don't know. Let's pretend like we'll just kind of go out on a limb here. Seals, I know they make noise, but let's pretend that they don't. Or let's pretend that we forgot to add a make sound function override. Okay, let's do it that one. A speechless... I'll just go with the first one that I saw. I've heard the... Alright, what does the fox say? Alright. So now let me ask you. What prints here? What do we see? What do you think we see? Put whatever this is in. Capybara, maybe? I put whatever that's in there, but it doesn't have the override. What do we see? What do you think? Has no sound. I'm the mammal, yes. I'm going to see I'm a mammal. And so what happened there was that it did reference its hierarchy. It did reference the hierarchy. Okay, it did reference it. Just gonna kind of do a terrible little Let's just pretend. Let's pretend I've made a professional diagram here. We're just gonna make it come. There we go. Oh, that's nice, isn't it? That's nice. Now it's capybara here. I'm sorry if I'm saying that wrong, but you guys know me. It doesn't have this. It doesn't have this override, right? It doesn't have a make sound. So we call make sound, and it comes up here to the base class, and it says, hey, this function is virtual. Now what's stored here? I'm going to go down the inheritance chain, and I found it. Does this even have a function override? No, it doesn't. So I'm going to use this one. I'm going to use this one instead. Okay? Exactly. It will go back up to the first function. Emma says, can virtuals reference pointers as well? It's kind of a hard question. I don't think... in terms of what we're talking about, virtuals only use functions for the most part. The only kind of thing you need to make virtuals work is a base pointer. But the only thing that virtuals will be affecting are the member functions and the destructor, which we'll get into next time. So to answer your question, I'm going to say no. Fuzzy asks, if the cat had a base class like Tabby Cat, but Tabby did not have a make sound function, would it use the make sound for the cat? Well, Fuzzy, we'll get into that next time, okay? We're going to have a lot of fun next class. Yep, we're going to make a whole bunch of classes, and you're going to know exactly how they work next time. To answer your question, I believe it would make the cat sound. I believe it would do a meow. Because it would go as far as it could, but then it wouldn't be able... So we'll see. We'll see. We'll test it out next time. So stay tuned. Or come to office hours if you want. We'll have some fun. That's all I got for you today. Sorry I held you 1 extra minute here. I guess that's not so bad. I hope you learned something. Hope you didn't fall asleep. I hope you had a great weekend. And I hope you guys have a great rest of your day. I'll see you guys next time. Please be on the lookout for your assignments and your test grades. Come talk to me if you need. That's all I got for you. I'm glad you learned a lot. You're welcome, Uchu. Yang, you are welcome. Cade, you're welcome. Kane, you are welcome. Turbo, virtual goodbye. How about a virtual you're welcome? CS202 student, you're welcome. Thanks for coming. YCS, you are welcome. Chef, you are welcome. Fuzzy, you are welcome. I look forward to seeing you next class. Hammer, whoop, voice crack. Hammer, you're welcome. Top Wolf, you're welcome. Synthos, you're welcome. Giovanni, you are, of course, welcome. Thank you all for coming to class today. Brandon, you're welcome.